Ever wished you could predict the future?
Well,
In a way, we
right.
can, thanks to something called machine learning.
Hmm.
Today,
Right.
we're going to explore two key techniques that power these predictions:
Yeah.
regression and classification.
You probably interact with these techniques every day without even realizing it.
Oh, yeah.
They're used to estimate everything from house prices to the best route for your commute.
It's mind-blowing how integrated they are.
Yeah.
What exactly is the difference between regression and classification?
Wow.
I hear they're both types of supervised learning.
Think of it like a teacher-student scenario.
Okay.
In supervised learning, the algorithm is the student,
Right.
and we, the data scientists, are the teachers.
Okay.
We provide the student with labeled data,
Oh,
like a set of math problems with the correct answers.
I see.
By studying this data, the algorithm learns to make predictions on new, unseen data.
Okay, so the algorithm is learning from our examples.
Yeah.
Just like a student learns from a textbook. Where do regression and classification fit into this?
That's where the student gets to show off what they've learned.
Okay.
With regression,
Uh-huh.
the student is predicting a specific number within a range,
Okay.
a continuous value.
I see.
Imagine trying to predict the runtime of a movie based on its genre, cast, and director.
Okay.
The output would be a specific number,
Got it.
like 115 minutes.
So it's not just about picking a category.
No.
It's about finding a precise point on a scale.
Right.
What about classification then?
Classification is all about sorting things into buckets.
Okay.
Instead of predicting a number,
Uh-huh.
the algorithm decides which category something belongs to.
I see.
Like that movie we're talking about,
Yeah.
classification could tell us if it's a comedy, drama, or action flick.
That makes total sense.
Yeah.
So it's like deciding whether a song belongs on my workout playlist or my chill out playlist.
Exactly.
Okay.
Another great example is your email inbox. It uses classification to decide if an incoming message is spam or not.
It's making a decision rather than pinpointing a specific number.
Right.
So if I'm getting this right,
Yeah.
regression equals a number output
Yes.
and classification equals a category output.
You got it.
Okay.
And the techniques for arriving at these outputs can get pretty complex.
Oh, I bet.
One classic technique for regression is linear regression.
Okay.
Think of it like drawing a line through a scatter plot of data points to find the best fit.
Uh-huh.
This line can then be used to predict the value of future data points.
I vaguely remember this from my high school math class.
Yeah.
But beyond just drawing a line,
Yeah.
how does that actually help us predict things in real life?
It helps us see trends in relationships.
Okay.
Let's take housing prices.
Uh-huh.
By plotting data points for square footage and price,
Yeah.
you can see if there's a relationship.
Okay.
If larger houses tend to have higher prices,
Right.
the line will slow upwards. We can then use this line to predict the price of a house based on its size,
Got it.
even if we haven't seen that exact house before.
Wow. That's
Mhm.
really helpful.
Yeah.
So we're essentially creating a predictive model based on existing data.
Exactly.
What about classification? What are
Mhm.
some techniques used there?
One popular method,
Yeah.
and this might sound confusing,
Okay.
is called logistic regression.
Logistic regression.
Despite the name,
Mm-hmm.
it's actually used for classification.
Okay.
It's particularly useful when you have a binary outcome,
Uh-huh.
like yes or no,
Uh-huh.
spam or not spam.
So even though it has regression in the name,
Yeah.
it's all about categorization.
Exactly.
That's fascinating.
Yeah.
What about situations with more than two categories? I imagine things get more complex then.
You're right, they do.
Yeah.
That's where we might use more powerful tools like neural networks.
Oh, okay.
You can think of these as incredibly complex systems with interconnected nodes, kind of like a digital brain.
I see.
They can learn from vast amounts of data to make very nuanced classifications.
Neural networks, I
Yeah.
always hear about those.
Right.
They seem like the next level of machine learning.
They are very powerful.
But it sounds like choosing the right technique all comes down to the type of problem you're trying to solve
Exactly.
and what kind of output you're looking for.
It's all about understanding the nature of your data and what you want to achieve.
Right.
Do you want a specific number prediction, or are you trying to classify something into a category?
So far, we've focused on the technicalities.
Yeah.
But I'm really curious to explore how these techniques are actually being used in different fields.
Sure.
Can we dive into some real-world applications?
Absolutely.
Yep.
Absolutely. One area where both regression and classification are making a huge impact is healthcare.
That's a field I'm particularly interested in.
Yeah.
What kind of applications are we seeing there?
Take medical imaging, for example.
Okay.
We can use algorithms to analyze X-rays.
CT scans and MRIs to help radiologists detect even the tiniest abnormalities that might be missed by the human eye.
It's like having a super-powered assistant working alongside doctors.
That's a great way to put it.
Yeah.
And these algorithms are constantly learning and improving as they're exposed to more data, which can lead to earlier and more accurate diagnoses.
Right.
That can be truly life-saving.
That's incredible. So it's not just about identifying problems,
No.
but also about helping doctors make better decisions for their patients.
Exactly, and it goes beyond diagnostics.
Okay.
Imagine using regression to predict how long a patient might need to stay in the hospital
Right.
based on their medical history and current condition.
That makes sense.
That can help hospitals manage resources more efficiently and improve patient care.
Wow. So these techniques are really optimizing all aspects of healthcare.
Yeah.
What about other industries? Where else are we seeing a big impact?
The financial world is another great example.
Okay.
Think about all the online transactions happening every second.
Right. Classification algorithms are working behind the scenes to detect potentially fraudulent activity,
Yeah.
protecting both businesses and consumers.
That's so important, especially with the rise of online shopping and digital banking.
Absolutely. And beyond fraud detection,
Mm-hmm.
these algorithms can help financial institutions make smarter decisions about investments and lending by analyzing market data and economic trends.
It sounds like machine learning is bringing a whole new level of sophistication to finance.
It really is. And then there's marketing and advertising.
Okay.
Have you ever noticed how websites seem to recommend products you might actually be interested in?
All the time.
Yeah.
It's a little spooky sometimes how well they seem to know my tastes.
That's classification in action.
Yeah.
Algorithms analyze your browsing history,
Uh-huh.
purchase history, and demographic information to personalize your online experience and target you with ads you're more likely to click on.
It's amazing how these seemingly complex techniques are being used to solve everyday problems and even shape our online experiences.
Yeah.
Are there any limitations to these techniques, though? It can't all be sunshine and roses.
You bring up a good point. It's important to remember that these algorithms are only as good as the data they're trained on.
Right.
If the data is biased or incomplete, the results can be flawed.
So it's not a magic bullet.
Right.
We still need to be careful about the data we're using and how we're interpreting the result.
Exactly. And even with good data,
Okay.
there's always the risk of overfitting.
Overfitting.
That's when an algorithm learns the training data too well
Uh-huh.
and fails to generalize to new unseen data.
It's like studying for a test
Yeah.
by memorizing the answers to specific practice problems,
Yeah,
but then being completely lost when you see a slightly different question on the actual exam.
that's a perfect analogy.
So,
It's a delicate balance between making sure the algorithm learns from the data, but also ensuring it can adapt to new situations.
I see.
It's also crucial to remember that these algorithms are tools.
Okay.
They can augment human decision-making, but they should never replace it entirely.
That makes a lot of sense. We need to use these tools responsibly and thoughtfully.
Precisely. And as these technologies continue to evolve,
Right.
it's vital that we have open conversations about the potential risks and benefits.
This has been such an eye-opening discussion. It's clear that regression and classification have immense potential to improve our lives, but it's also important to be aware of the limitations and use them ethically.
Couldn't have said it better myself now that we've explored these two techniques in depth.
Yeah.
I'd like to leave you with a thought-provoking question.
Okay.
What happens when we don't have neatly labeled data?
Hmm.
What about all the unlabeled data out there in the world?
That's a great question.
Mm.
It sounds like there's a whole other dimension to machine learning that we haven't even touched on yet. You're right. That's where unsupervised learning comes in.
Yeah.
A whole other branch of machine learning where algorithms try to find patterns and structure in data without being explicitly told what to look for.
Imagine giving a child a box of different colored blocks
Okay.
and asking them to sort them.
Yeah.
They might group them by color,
Right.
by shape, or even come up with their own system. That's kind of what unsupervised learning is like.
So instead of giving the algorithm a set of rules,
Right.
we're letting it discover the rules on its own.
Exactly. It's all about uncovering hidden patterns,
Okay.
grouping similar things together, and making sense of complex information without any predefined categories.
That sounds pretty powerful.
Yeah.
Could you give us some examples of how unsupervised learning is actually used?
One common application is customer segmentation.
Okay.
Let's say you're an online retailer with millions of customers.
Right.
An unsupervised learning algorithm could analyze purchase history,
Uh-huh.
browsing behavior, and demographic information to group those customers into different segments based on their shared characteristics.
So instead of deciding beforehand what a frequent buyer or a budget shopper looks like,
Right.
the algorithm figures that out on its own.
Precisely, this allows businesses to target their marketing efforts more effectively, recommend products that are more likely to be purchased, and personalize the overall shopping experience.
That makes a lot of sense. It's like the algorithm is uncovering hidden tribes within a customer base. What other applications are there?
Another exciting area is anomaly detection.
Anomaly detection.
Okay, think about credit card fraud.
Okay.
An algorithm can analyze millions of transactions,
Right.
looking for patterns that deviate from the norm.
So it's like a detective looking for clues that something is out of place.
That's a great way to think about it.
Yeah.
If a transaction looks suspicious,
Uh-huh.
say a sudden large purchase from a different country,
Right.
the algorithm can flag it for further investigation.
That's fascinating.
Yeah.
It seems like unsupervised learning can help us identify things we might not even know to look for.
Exactly. And as we generate more and more data,
Mm-hmm.
this ability to find hidden patterns and anomalies becomes even more valuable. It can help us prevent fraud, improve cybersecurity, and even make scientific discoveries by uncovering unexpected relationships in complex data sets.
This has been an incredible journey through the world of machine learning. We've gone from predicting movie runtimes to uncovering hidden customer segments. Who knew algorithms could do so much?
And this is just the tip of the iceberg. Machine learning is a rapidly evolving field with new techniques and applications emerging all the time. It's an exciting time to be exploring this space and to see how these technologies continue to shape the world around us.
I couldn't agree more. Thanks for guiding us through this deep dive into regression classification and the fascinating world of unsupervised learning.
It's been a pleasure sharing these insights with you. Until next time, keep learning, keep exploring, and never stop asking questions.